Hello class, this is a video tutorial on trigonometric functions and the graphing of them. In this video we'll be looking at an example of graphing a function of tan. So, unlike with sine and cos, the critical points that we need to remember for tan are its asymptotes that I've highlighted here and its x-intercepts. Now, to understand this graph, what we do is we consider first the easiest transformations. So in this case, I'm going to be looking at the transformations of the phase shift. So let's look at the shift first. Well, like with regular transformations, if we had f of x, to move it to the right, so right movement, we replace x with x minus h. To move it to the left, we replace it with x plus h. In this example, we have a minus pi on 4, which means everything has now been moved a quarter distance of pi to here. So already we should be imagining, so let me write this in, our shift is to the right by a distance of pi on 4. So 0 is now pi on 4. This asymptote is now 3 pi on 4. This asymptote should be now negative pi on 4. And this first cycle of tan should now look something like this in your mind. Very rough sketch. There we go. So it's been shifted to the right already by a distance of pi on 4. Now we're going to combine that with the period change of this value of half. We can consider this as a transformation of a dilation of the x-axis, the x distances from the y-axis. So if we consider this as a distance, the distance from 0 to pi on 2, well, that's pi on 2. This transformation is a dilation which doubles this distance. So if it's currently pi on 2, this distance will now be pi on 4. Okay, so it should be here. However, because of the phase shift, we're going to move this point, this asymptote, one more distance of pi on 4. So this asymptote is now transformed to be here. This time I'm going to leave this point there because that's going to be my actual graph. This point here has actually been shifted to pi on 4, so I'm going to draw this point in here. This distance here is currently pi on 2. It would be stretched to become if this has been moved outward, the same thing will happen to this asymptote. It's a distance of pi on 2. It will be moved in distance by a factor of 2, but then because of the phase shift, this asymptote that would be here is moved to the right one more time. Okay, so the asymptote we are looking for is actually here. From this, we are able to graph this first cycle. It's a very wide one, and it will look something like this. Has to intercept at that point that we've marked and cycle up to this asymptote. There we are. Now, because we know this is what it'll look like, everything else will cycle similarly along the asymptotes, like so. So I'm just going to mirror this along here, which should be like so. Whoops. It should cut off at pi, at negative pi, sorry. There we are. And likewise, this point here should mirror this point here. So it'll be something along the lines of like so. This one is a lot more conceptual. You need to think about it far more than you would with sine and cos. And you should be thinking of this as more the dilation of the asymptotes away from the y-axis. I hope that gave you an insight into the transformations of trigonometric functions using transformations. Hope to see you in the next video. Best of luck.